For question 14, part A is asking us to show that the lines 3x minus 2y equals 1 and y equals 5x plus 10 are not parallel. So I'm just going to rewrite these equations here. This is part A. 3x minus 2y equals 1 and y equals 5x plus 10. So we know that for two lines to be parallel, their slopes have to be equal. So for these two equations, we want to show that their slopes are not equal. And if we look at this first equation, this is in the form y equals mx plus b, where m is the slope. So it's pretty easy to figure out the slope of this line. It's just 5 here, the coefficient on x. So the slope of this line equals 5. For this first equation, we kind of have to rewrite it a bit to make it in the form y equals mx plus b, and then we can see what the slope is. So to do that, I'm going to add 2y to both sides. This gives me 3x equals 1 plus 2y. Now I'm going to subtract 1 on both sides. This gives me 3x minus 1 equals 2y. And now I'm going to divide both sides by 2, which gives me y equals 3/2 x minus 1/2. And so this is a little backwards, but it's still in the form y equals mx plus b. And so we can see that for this line, our slope is 3/2. So we can see that 3/2 is not equal to 5. So therefore, our lines are not parallel. So moving on to part B, I'm just going to section off this part here. Part B is asking us to find the coordinates of the point of intersection for these lines. So value of x and y that simultaneously fit both equations. And so since we know that these two lines are not parallel, that means they have to intersect at some point. And this is what we're trying to find in part B. So to do this, what we want to do is get an equation where we only have one variable, and then we can solve for it. So we know that for this point of intersection, our x and y have to be, or our our value for x for both equations has to be the same, and our value for y for both equations has to be the same. So with the second equation, y equals 5x plus 10, we have an expression for y in terms of x. So we can use this to plug into our second equation, where we have 3x minus 2y equals 1. So I'm going to plug in 5x plus 10 in for y here. This gives me 3x minus 2 times 5x plus 10 equals 1. So now I have an equation where the only variable is x, and so I can solve for x here. So I get, multiplying that 2 in gives me 10x. Multiplying -2 times positive 10 is -20. That equals 1. And so I'm going to combine like terms, and 3x minus 10x is -7x. Sorry, let me rewrite that line. So it's -7x minus 20 equals 1. Now I'm going to add 20 to both sides of my equation. This gives me -7x equals 21. I'm going to divide by -7 on both sides, and this gives me x equals -3. So now I have a value for x, and I can plug this back in to this equation, the first one here. So that's going to be the easiest. And plugging in -3 for x here, get y equals -15 plus 10. And that gives me y equals -5. So I have x equals -3 and y equals -5 for this system of equations. And a good thing to do now is to check that this makes sense in our second equation. So I'm going to check that here in this equation by plugging in these values for x and y. So it gives me 3 times -3 minus 2 times -5 equals 1. This is -9 plus 10. And -9 plus 10 is indeed 1. So this check works out, and we can be confident that the coordinates of the point of intersection are x equals -3, y equals -5. And that's the answer to part B of question 14.